My name is Timothy Pichet, and this is my video submission for the technical presentation all about thermal expansion. So what is thermal expansion? Thermal expansion is a concept in physics that relates the temperature of an object to its dimensions. As seen in the first equation, if you have the original length of an object and its change in temperature, then you can multiply those two by the coefficient of thermal expansion to get the new length of the object. In the same way, you can find the new volume of an object that undergoes a temperature change by multiplying that change in temperature by the object's original volume times the coefficient of volumetric expansion, which is just 3 times the thermal expansion in the linear direction. In order to understand this concept of thermal expansion, some basic prerequisite information must be known. First of all, a basic knowledge of calculus must be understood in order to find the coefficient of thermal expansion. As seen in the first picture, derivatives are used to find that coefficient, since the reciprocal of the length times the change in length with respect to the temperature is equal to the coefficient. This coefficient will be used in all of the thermal expansion equations and should be constant between materials. Second of all, the basic concept of strain from statics must be understood too. Since thermal expansion is a type of strain, it'll be used in each one of these situations. Strain is measured as the change in length over the original length of the object, at least in the normal direction. So in total, strain would be the change in size of the object, or a change in dimension, which is what thermal expansion covers. Now, in order to see this concept of thermal expansion in action, let's take a trip to the lab really quick. In this experiment, we're going to witness the effect of thermal expansion on a small copper ring. So, I have these small copper rings that I kept in the freezer for a while to make sure they were extra cold. As of right now, the diameter of the ring does not fit over this nail die. But let's see what happens when I heat it up a little bit. For this, I'm going to be using this propane torch to heat up the copper ring and see what happens and if it'll fit over this nail die. And as always, when you're working with fire, make sure to have your fire extinguisher on hand, wear some gloves so you don't burn yourself, and as always, wear your safety goggles. So let's go ahead and turn on this torch and light it up. To do so, I open the gas, hit the lighter, and I hold it directly over the ring. As the ring heats up, it starts to change colors a little bit. Alright. Should be almost done. Alright, we're going to close the gas can. And now, we'll place it on the nail gun. And the ring got a little warped in the heating process, but as you can see, it fits a lot better on the nail die now, since it has a new wider diameter. And if I give it a few more taps, it should fit farther on. Just like that. Now, although that's a pretty fun experiment to do at home, to try to increase the diameter of the ring to fit on certain other cylinders, let's see some practical examples in the engineering world of thermal expansion put to use. First of all, when civil engineers are designing structures that are exposed to environments, they have to take into consideration thermal expansion when designing the structure. As seen on the left picture, these teeth at the end of a road are at the beginning of a bridge. So whenever a bridge is exposed to different temperatures, it may have the potential to expand and contract depending on the temperature. Those teeth allow that bridge to expand and contract without cracking, so it can adjust its size correctly to the changing temperature. And on the right, there's also another example of this. At one end of the bridge, there's a fixed end that's not supposed to move. However, on the second end, there's a roller on the bridge that allows the bridge to move in the x direction. This allows the bridge to expand and to contract due to temperature and not have the bridge be damaged itself. Another practical example of using thermal expansion in engineering designs is the design of a smoke detector switch. One of the best ways to detect a fire in the room is by using a switch made of two different materials riveted together. One of the materials will have a different coefficient of thermal expansion than the other, and whenever the switch heats up, one of the materials will increase dramatically in length, while the other one will not increase dramatically in length. This allows for a detection of temperature to be had in the room, so the switch flips and the smoke detector goes off. So there you have it. Explained simply, thermal expansion just means that temperature change means dimension change. If you increase the temperature of an object, then its dimensions increase. If you decrease the temperature of an object, then its dimensions also decrease. Though this has many practical examples in engineering, changing temperatures of an object can literally mean a change in the size of the components you're working with, and that means a very important impact on what you are trying to design. My name is Timothy Pichet, this has been Thermal Expansion, and as always, thanks for watching.